How many?
20.
20. How many? 5. I can't count anyway. Come on.
Why scare them? And they call me barbarian.
That was a hard one to get all the timing right. So, for this homework, which is called Bad Explanations, it's very similar to the other homework called Explain Statistics, except it came about differently. Many times on final projects, I saw consistently the same kinds of lines coming. And so I used to have a homework where it said, this is what people say, figure out what's wrong. And then I would have multiple versions of the same thing. I figured out it's a better way to do the homework to just say, pick out the one that's right, which makes it similar to the Explain Statistics assignment. Let's look at it. Here we have a p-value that is large. What is the correct conclusion that you should make when a p-value is large? Things about r squared. Some of these may be related to regression stuff, such as the r-squared questions that you may or may not be very familiar with. Here is your chance in a nice, safe way. It's 1 of 5 chances. If you mess up, it means you have to redo it. Here, my 2 favorite questions on this quiz. One where the p-value is large. Normally that would be bad because a large p-value means that you can't prove anything, but a high r-squared, which seems good. A little later we see the flip side where the p-value is really small, which is good because you've proven something, but the r-squared is terrible, which makes you think it's bad because now we can't predict things. So given how much students have struggled with those 2 questions in particular, I want to take just a short while to talk about it. If we were doing regression and we had a small p-value, which is good, and a high r-squared, which is good, that probably means we're talking about data like this. Is it provable that there definitely is a relationship? Sure, so that would give us a really small p-value. Can you get good predictions off of it? Yes, the data is really close to that regression line, so the r-squared would probably be about 0.99. That's the nice ideal situation. The opposite is also easy to understand. Here's a bunch of data, it's just in a cloud. Is there much of a relationship? If there is, it's not very provable. That r-squared is terrible because we can't get good predictions. So bad p-value, bad r-squared. But is it possible to have that weird situation where the p-value is terrible because it's so large, but the r-squared's fantastic because you want that to be large? And the answer is yes. Here's how it happens. With those dots, a regression line would look really good. You can't see those dots. I'm going to make them bigger. So the dots follow the regression line very closely, hence the great r-squared. But can you prove this relationship with only 3 data points? There's not enough data to really say that we can be certain that there is a relationship, hence the bad p-value. There's also a situation where you can have a great p-value and a terrible r-squared. P-value, you want it to be low, r-squared not so much. How does this happen? Well, the slope here is subtle, but there is lots and lots of data to support it. There absolutely is a slope that is provable, hence the small p-value. But do you get good predictions? Well, without knowing the x-value, you predict somewhere in this range. Thanks to knowing the x-value, your range shrinks a tiny amount, like 1%, but it really doesn't help much. And so here's a scenario where the p-value looks good because it is provable that there's effect, but the r-squared's terrible because it's hard to make predictions. And it's important for you to understand the difference between these two. This talks about how much can we prove that that slope is significant. This says how good are our predictions going to be, and those are not the same thing. And in fact, scenarios like these happen a lot in real life. So go through the homework, and if there's questions where you feel like, oh, that's the way I would have said it and it's wrong, that's normal, nothing wrong with you, but now you get a chance to say, I can see why it's wrong, or if you can't, bring it up, post on the discussion board or ask so that you can figure out why it's wrong.